Hi, my name is Dwayne Bone. This is my screencast of the CS 499 Computer Science Capstone course Milestone 1 Code Review. The artifact I will be covering is from the second final project in the CS 430 Client Server Development course. In the lower left corner of my presentation, you can see the table of contents outlining what I will be covering. I've inverted the order of operations from the example review presentation video. I believe this method of grouping the course objectives into the review categories is easier to understand. First, I will explain the original project specifications and purpose. I will then go through the current functionality for each outcome category. After that, I will perform a code review of the project, and finally, I will cover the enhancement plan and objectives. The project is composed of two Python files. The first is the project2dashboard.py file, which contains the business logic, and the second is the animal_shelter_py file, which contains the create, read, update, and delete CRUD MongoDB methods, as well as the ability to connect to the database and authentication. The project is a web application service designed for a hypothetical company called Grazioso Salvieri. The company required a web interface to the local Austin Animal Center outcomes database to search for potential dogs that could be trained for search and rescue. The application was implemented using the Python Dash module. The module provides dynamic web interfaces using a custom, highly integrated application stack. It builds pages using Python code and integrates them with a mini JavaScript Express.js stub application for dynamically updated data display components. It uses predefined MongoDB search queries to filter the full animal database into three groups of dogs that fit the categories of water, mountain or wilderness, and disaster or individual tracking search and rescue jobs based on predefined parameters. The retrieved data is transmitted to a two-dimensional array formatted for the Python module pandas to an Express.js stub application that displays it in a spreadsheet format. The Python Plotly Express module provides a pie chart showing the breeds of the animals currently in the spreadsheet. The Python module -leaflet provides a Google Map style geolocation component showing the location of any animal selected in the spreadsheet. Selecting an individual animal will update the map component, centering it on the animal's location and adding a map pin indicating the animal's breed. Hovering over the pin displays the animal's name. Now I will be covering the current functionality in each of the Python source files. The business logic is contained in the project2dashboard.py file. It loads the module dependencies, including multiple components of the Dash module. The Dash module constructs the web page content and transmits the animal information to the Express stub application. In addition to the Dash extension, the -leaflet extension allows embedding an interactive map in the Dash application using the leaflet mapping engine. The Plotly Express module is used to create an additional pie chart showing the breakdown of all the breeds of the animals in the current dataset. The OS module was loaded for interactive loading of the operating system environment. This was originally used to get the environment variable values to set runtime parameters. The logging module has been loaded for outputting activity messages as well as debugging messages. The NumPy pandas and matplotlib modules were imported for manipulating dataset values and plotly data. The CRUD implementation module written by me is loaded for the Austin Animal Center's shelter outcome database. The logging subsystem is initialized at line 33. Three static symbolic constants are defined: the GPS location for Austin, Texas, the style, height, and width of the geolocation map, and the MongoDB filter queries defining each of the search parameters for the different categories of search and rescue dogs. The username and database variables are defined, and a complete download of all of the records in the database is stored. The ID field is dropped from the data to avoid issues with the web application interface attempting to parse the Python object ID stored in it. The Dash web application object is created, and the two Grazioso Salvieri logos are loaded from files. Next, the dynamic HTML web content is constructed using the Dash HTML tag component functions. They construct the web page programmatically, mimicking how the HTML markup language works. Next, the dash callback procedures are defined. These handle the user interaction with the web page components. The first step is for the user to select an option from the filter drop-down menu. Then the callback updates the animal breed pie chart whenever data is changed in the data set. Next, the Google-style geolocation map is updated when an animal row is selected in the dataset display. It selects the appropriate row from the two-dimensional dataset matrix and retrieves the fields appropriate to the map. This includes the GPS location, breed, and name of the selected animal. When the animal's row is unselected, it resets the map using the same method and recenters it on Austin, Texas's GPS location. Next, I'm going to cover the database access module called animal_shelter.py. The database create, read, update, and delete module code is straightforward. The module defines an animal shelter class. This includes a constructor that takes a full set of MongoDB database connection setting variables. It attempts to establish and save a database connection and logs an error if it fails. Each method in the CRUD stack is implemented. Additionally, there is a getCursor method that is no longer being used. Originally, it was used to get inline data for updating specific Panda components. Finally, there is the close method all the way at the end of the file. And all it does is it sends out a message saying it's closing the connection and closes the connection to the database. Now I'm going to begin the in-depth code analysis, starting with the first project2 dashboard.py file. I'm going to be jumping around through this file a bit during the code review, so hopefully it's not too confusing. So the business logic code is complete. It's correctly implemented based on design specifications of the project documentation. The code conforms to Python code syntax and commenting standards. Got line 215 here. The code is appropriately structured, consistently styled and formatted. Appropriate comments have been added to all key code blocks describing what is being done. One code block that starts at 215 should have an explanation about what it does. I missed that and should add that as a task for putting the comment in there that would appropriately explain what that block of code right here is doing. The code is essentially just populating the database stuff into a two-dimensional array that's uploaded to the front-end application stack. There's no unexecutable code. There is one block of leftover code that's a fully written code at line 298. Let's see here. It's right here. This code is no longer used. The original purpose for it was to allow for the columns in the database table, the spreadsheet, to be able to be sorted by clicking the headers of each of the columns. There's no code that could be replaced by calls to an external reusable component or library functions, nor are there blocks of code that could be consolidated into a single procedure. All of the code represents one-off implementations. Any replicatable code is dynamically generated by the Express.js application stub. No local storage is used for the data. In fact, there's no files that are stored as part of the application at all. The only thing that's loaded are pre-static image files for logos and things like that. Two static files containing those logos are loaded at the top at approximately line 126, right here. These particular blocks of code should have implemented a verification block to confirm that the files are actually present before attempting to load them. So that will be fixed. As stated before, two symbolic constant variables are defined at the beginning of the file. There are two string constants defined at line 99 and 100. These are the user and password settings for accessing the MongoDB database. This was defined this way as part of the procedure and design of the application itself. This was specified by the instructor as well as the instructions of the project. So it has something to do with using Jupyter's notebook Python virtual environment for testing and grading. So this was defined this way. As part of the update to the project, this will be replaced, and these environment variables will be assigned by way of environment settings in the operating system. The code documentation formatting is carried forward from the original comments placed in this framework file. This file was originally a skeleton that had commented sections instructing you to fill in the sections with new code. I just continue to use the defined comment formatting from the previous file. All of the comments are consistent. All the variables are properly defined. They have meaningful names associated with them. They're concise and clear names. All variables maintain appropriate typing. No variables are used for general storage or transient data types or anything like that. They don't switch data types or values. There are no redundant or unused variables. However, there are a couple of modules that are being loaded that are no longer applicable and should be disabled. This includes the NumPy and the matplotlib modules. They are no longer used and should be removed. The code doesn't have any mathematical operations of significance. The only comparisons are handed off to the MongoDB database for evaluation against field values and are integer based. No floating point comparisons, roundings, differential magnitudes of values, or division by zero, or any kind of noise errors are possible. There's no floating point mathematics being done inside of the primary code. All of the loops, branching code, and logical constructs are complete, correct, and properly nested. There was no data provided by the project from the perspective theoretical customer, specifying any kind of predefined or commonly used hierarchy of queries or data organization. So there were no specifications. They were just loaded as they were indicated in the documentation for the project. The if-else statements in the update dashboard method at line 266 need to be updated. They are missing any kind of default else case that defines a query to retrieve the entire data set. So if there is no specification for the query, or there's some kind of error where the query was not properly passed to this function, it should fall back on loading the whole entire data set and just updating the whole entire display. The if-else statement at the 332 line is working properly. It avoids having any problem with a default value or missing a default value because at the beginning of the if statement, it determines if neither of the two primary variables are set properly, that it just returns immediately, which will not update any of the content on the web interface. There are no case statements used anywhere in the code as well. There is only a single loop statement or for loop statement at line 220. It has no vagueness in terms of its termination condition and works as expected. It operates essentially as a list and just iterates across the list. And the list iteration process contains its own limiting factors, so that works as expected. Just going to quickly cover some of the requirements just to clarify that some things are just not implemented. There are no indexes, pointers, subscripts that are used to access dynamically allocated memory or anything like that. Python doesn't really support that. It does support subscripts, but those are in explicit lists and don't have problems with accidentally going beyond the assigned memory allocation or anything like that. So where indexes are used, they are inside loops specifying the iteration method and its valid limits. They iterate over a list that defines its own bounds, so there's no problem with any of that kind of stuff. And again, the variables that require a valid value for execution, a default value is always assigned in my code. This essentially, even if it's something like undefined or none, it will catch that and determine that some kind of issue has occurred and indicate that some kind of process has failed. So there are no external devices or files being accessed or edited, so no states need to be cleared up or verified before the end of the program execution. Now I'm going to cover the animal shelter py file. This is the only file that I explicitly created with no kind of skeleton framework where I had to fill in things. This is completely self-contained code. So I'm going to go to the top here. The code is complete and implemented in accordance with the design's technical specifications. The code conforms to both Python coding standards and module implementation standards. The code is well structured, consistent in style and formatting. The file didn't have a skeleton template, so I wrote all of the code. There are currently uncalled methods specified in the class, specifically the getCursor method at line 87. This method was originally used for accessing a cursor for dynamically loading components of the database outside of the web application's updates to the data set for viewing by the client, the web client. The second method that's technically not used is all the way at the end. It's the close method. So the reason why this is not used is because the whole entire application is running inside of a Dash instance. Attempting to close the database while the Dash instance is still running causes an error because the Dash instance is storing the database access point. And if you attempt to close the database while the Dash instance is still open, it causes an error to the Dash instance. Normally, the Dash instance itself controls shutting down the application. In the documentation, it does say that it appropriately closes database connections. So essentially, you'd never use this method. However, I do want to keep it there because it is a valid method that should be used in any other circumstances if you were to use this class for accessing the database for the animal shelter data. The code is clearly and adequately documented with an easy-to-maintain commenting style using the PyDoc framework. The PyDoc framework implements class and function and code comment similar to the JavaDoc specification. Any IDE that supports the PyDoc documentation formatting will display help dialogues whenever you hover over any procedure, regardless of where you are in your source code. The IDE will search out the components that you're hovering over inside of their class or whatever module file that they're in and display the comments inside of the triple quote blocks inside of the code. So in this case, we have the animal shelter object or class. So if you hover over the name of it, it just displays that one line thing right there. But the constructor has a bit more information. This includes the arguments and things like that are specified in the comment block. So if I hover over that, you can see that whole thing there. This works throughout the interface for the IDE. So if I were to go to one of the methods here, let's say the read method, and I were to hover over that, I would see the comment in here. But if I also hovered over it in here, I would also see the same arguments and return value commentary as is inside of the main class. This also works to make the comments consistent with their associated code. Obviously, the comments are going to be associated with the methods in class that they're contained inside of. This is a standard comment methodology as well. So it works both as a standard comment methodology as well as IDE compatible displaying of pop-up information whenever you're developing code. All of the methods that support it have specified return types. So here you have a list being return type. The return types are recommendations or hints. They actually don't enforce anything with regard to the compiler, so technically any of these methods can return an incorrect type, even if you specify it here. In some cases, you can't return types, especially if it's a complex object of some kind, so like a class object that's been instantiated. In the case of this deprecated getCursor method, it does not have a type specified because when you get a query return from a MongoDB database, what you're actually getting is the MongoDB object ID, and it fails because it's a whole entire object at that point, and that is not something that can be returned as a fixed type. All of the variables are properly defined with meaningful and consistently clear names. So all of the variables are also consistently typed. I'm not switching types or the content of the variable itself, like between floats and strings, or whenever variables are defined and used for their specific purpose and do not switch types. There are no redundant or unused variables in this particular module. Again, with the exception of the aforementioned getCursor method, which is deprecated and will be removed. There are no specific math operations in this module. So any potential float point comparison problems, rounding issues, differential magnitude operations, or division by zero, or any kind of division noise levels are not possible because none of the math activity is going on. The only time you might see math is in the queries in the previous file, where some of the database queries are actually checking for a value in a column based on an integer. And that is handled by the database and whatever computational methods it uses to accurately determine greater than, less than, or equal, or any of the other mathematical comparisons is contained within that module. So now I'm going to cover the enhancements that are going to be performed on the primary application stack. So the application code enhancement will involve splitting the current integrated backend and front-end components. The backend will be re-engineered as a full-stack REST API using either Python Fast API or Java Spring Boot frameworks. This will be a full API stack with a single static web page endpoint for delivering the front-end web application. The enhancement will expand the application functionality and make it portable through compatibility with container technologies such as Docker, Kubernetes, as well as cloud platforms like AWS. The front-end web application will be built using Express.js. It will reproduce all of the same functionality from the original current application, but more efficiently and responsive by reducing the amount of data transmitted back and forth between the front-end and back-end, and dynamically manage how to load and when to load data from the database based on the user demand, such as pagination or things like that. Requests for new data triggered by the user, such as filtering, sorting, pagination, will be handled on demand by the Express.js app and fulfilled by the API endpoints. A new security API endpoint will be created. This will address the security issues of the original application, which was designed as a standalone portable application just for viewing the data. So it was deployed on demand to whoever wanted to use it. This one, because it's deployable to some kind of cloud environment or a standalone application stack on a server or something like that, it needs some method of handling user authentication and authorization for the application. An associated Express.js application component will be created for that, and that will facilitate any of the security requirements through an endpoint. Now I'm going to go through the algorithms and data structures current functionality of the application stack. There isn't much in terms of these standalone algorithm implementations for this project. The code is utilizing specialized data processing modules. There are basic flow control code blocks, as well as areas of business logic that use self-constructing data via Dash, essentially using Python language structure as an algorithmic framework for constructing web pages. You can see this at line 134 in the first file. So if you look at that in 134, you can see the whole entire website being constructed using this kind of language structure to execute individual HTML tags as functions and construct a whole entire web page using that. The data structures in the MongoDB database are treated like fields in a relational database. They are passed around and processed in code as a two-dimensional matrix. There is no attempt to implement any kind of object relational mapping. All or some of the database is converted into a matrix and transported around, as is up to the Express.js stub application. The enhancement for this particular outcome requirement is to completely convert this to a ORM, or an object relational mapping structure. This means that the data retrieved from the database will be processed into class objects. Because the new architecture will reconfigure the backend to provide a full REST API stack, the data needs to be processed into classes that can be transformed into, for example, JSON documents to and from other data formats. This will facilitate the use of the full Express.js application stack for the front end of this application, with incremental data transfers and things like that, making a movement of the data in between the front and back end more efficient. The data transformation algorithms will be required for these full stack application activities. The new algorithms will convert outgoing ORM data objects into lists with JSON documents. Request to update data from the Express.js application will be converted to a class object and processed with the equivalent ORM layer. So that will make things much more efficient and logical, as well as supporting future potential functionality with endpoints that are not the application. Let's say contracted users that want to use the same endpoints as the application does, using their own scripts or processing in the backend. So now I'm going to cover the database outcomes category current functionality. The database layer currently uses a MongoDB database to store raw data from the Austin Animal Center converted from a comma-separated values file, or a CSV file, into individual documents with each field based on the CSV columns. This is functional, but it is a inefficient use of a document data store like MongoDB. The database documents are very small, importing a CSV file like this. The fields can often contain well-defined numerical types, string fields with limited values, repeating values, things like animal color or the sex of the animal, and the occasional irregular data field is usually a small string, things like the animal's name or something like that. The current application server implementation using MongoDB fetches the entire data set repeatedly and transmits it back and forth to the front end from the back end application service. So now I'm going to cover the enhancements to make this work better. The database enhancement will be a conversion from MongoDB to a relational database, specifically a Postgres compatible relational database. The reason for this, as I stated, the shallowness of the source data. The document store, like MongoDB, is not really designed to efficiently process something this shallow, essentially equivalent to a spreadsheet in terms of data, as quickly as something like a relational database. They can store this data, but are less efficient at processing it than a relational database, just because of the way that it's formatted. The original data is stored in the CSV file, and by its very structure, more resembles a relational database, specifically a SQL database. Essentially, it's just a spreadsheet. Both of them kind of look that way. And this isn't a humongous data set in terms of depth. This will require updates to the database creation and data import process. So the database tables are going to have to be defined, as well as their fields. And then Postgres does have command line utilities that will import CSV files once the database structure is defined. The MongoDB CRUD client module will have to be updated, and all of the procedure code will have to be replaced with SQL-based query code. The module will also be shared between the database module as well as the API endpoint code. So instead of transmitting these arrays and lists and two-dimensional matrix arrays, it will use object relational mapping. And so what they will be exchanging is actually objects based on classes that contain fields that are associated with the fields that are used by the table or tables. And again, this will also include implementing of the new tables associated with user authentication and authorization. So all of this will include upgrades to the database for that as well. In addition, some of the fields that are in the database rows have the repeated use of specific strings and things like that. And those particular fields can be converted to enumerated lists inside of the database rather than attempting to process them as strings over and over again. This makes the whole entire search process using those fields much faster. Also, it'll remove the necessity, if you wanted to process it inside of the code as a enumerated list, of having to translate things back and forth. So some of those fields can be processed out to isolate the limited number of options that are in those fields and then convert them to enumerated lists inside of the database. This can also work with the object relational mapping. And so overall, it will just increase efficiency generally and increase the efficiency of queries by allowing for pagination at the database level so that you don't have so much data going back and forth between the endpoint and the front-end application. So that should improve a bunch of things. Thanks. This is the end of the presentation of my code review. Thanks.